Hi guys, so welcome to the very first chapter of this course, Solving Linear Equations Using Trial and Error. In this lecture, we're going to learn a few common terminologies that are commonly used in linear equations, as shown on the screen. So let's start with the very first one. We have unknown variable. Now, variable is a term that you're going to come across a lot when it comes to algebra and linear equations, quadratic equations, etc. A variable is basically just a letter that is used to represent a number. It's unknown until we solve the actual equation that we're working for. So variable, just remember guys, just means a letter that is being used to represent a number that we don't know yet. So the letter could be anything, could be X, Y, T, Z, C, D, anything you want. Out of the 26 letters, we can use any one of them. The next common thing that you're going to hear of a lot is the term expression. Expression is basically a mathematical phrase that consists of numbers and variables. So a simple one here could be 2x plus 5. So that right there is an expression. And to finally finish off our definitions, we have equation. An equation, pretty straightforward. It's an expression that is equal to a constant or another expression. So an example is 2x plus 5 equals 7. A constant, guys, simply means a number on its own. In the world of linear equations and algebra, a constant simply means a whole number on its own, right, like that one. So an equation could be, like it says, 2x plus 5 equals 7. That's an equation. It could be 2x plus 5 equals 3x minus 4. That is also an equation because that is one expression equaling another expression. And we use equations to describe a problem that needs to be solved. We're going to have a look at a number of these in future lectures. So guys, to kick off things, let's learn how to write equations based on some simple information that is given to us. Alrighty, so let's have a look at the very first question that we're going to make our way through. It says, write an equation to represent each of the situations below. Part 1 says, I'm thinking of a number. When I multiply the number by 6, I get 24. So guys, in situations like this, it's a very simple sort of a scenario. The very first thing you'll notice, it says, I'm thinking of a number. Now, they haven't told us what this number is. It's simply, I'm thinking of a number. When I multiply the number by 6, I get 24. So there is absolutely no indication of what the number is. Therefore, because this is unknown, as we went through our definitions just earlier, this is an unknown, so we use a letter to represent this random or unknown number. So we can use any letter that we want out of the 26. So let's pick A. So A is basically the number that we are thinking of, or A represents the number that we are thinking of. Then it says, when I multiply the number by 6, I get 24. So I have my number A multiplied by 6, which gives me 24. I have literally just taken the information that they've given me, and I've written out what we call an equation, because we have an expression here, which is A times 6, which equals a constant, or a number on its own, which is 24. So A times 6 equals 24. Now guys, when it comes to algebra and when it comes to linear equations, we don't use the multiplication sign. We don't need to use it. So the way we represent two things being multiplied to each other, so a letter being multiplied to a number, we simply write the number and letter next to each other. So it becomes 6a, which is equal to 24. And the number always comes first, then it's the letter. So that's just a general rule when it comes to algebra. So to represent, so it says write an equation to represent each of the situations below. I'm thinking of a number. When I multiply the number by 6, I get 24. That equation right there is 6a equals 24. Now let's move on to B. It says I'm thinking of a number. When I divide 40 by this number, I get 8. So again, we have an unknown number here that we don't know what it is. So we can attribute any letter or variable that we want. So let's pick S this time. The question says, when I divide 40 by this number, so I've got 40, and I'm dividing it by S, which will then give me the number 8. So again, guys, there's another equation that we've just constructed using the simple information that we've been given. Now, just like multiplication, division, the division sign, is not actually used in algebra, linear equations, etc. The way we represent division is by writing it out as a fraction. As we know, the line in a fraction simply means divided by. So we use the fraction to represent a division scenario. So it becomes 40 over s equals the number 8. So that right there, guys, is an equation that represents a situation that's being described for part B. Let's move on to part C now. It says, I'm thinking of a number. When I subtract the number from 7, I get 5. So again, another unknown number. Let's give it the letter X this time. So it says, when I subtract the number from 7, so we are subtracting it from 7. So we have the number 7, and then we are subtracting the number X from it, which then gives us the answer of 5. Now, unlike division and multiplication, we can write the takeaway sign when it comes to linear algebra or linear equations. So 7 minus x equals 5 is our final answer. Now guys, for the very final question, which is part D, I would like you to pause the video at this stage and have a go at this question on your own and see how you go. And we'll come back to it in a couple of seconds. Alrighty, so I hope you had a chance to have a go at part D on your own. So it says, I'm thinking of a number. When I add this number to 9, I get 13. Okay, so again, another arbitrary number. So we can give it any letter we want. You might have chosen Z, you might have chosen C, D, whatever you like. Doesn't really matter. I'm going to choose the letter Y. So it says, when I add this number to 9, so I have the number 9, and I'm adding the number Y to it, or the letter Y to it, which represents the number that I'm thinking of here. So 9 plus Y will give me the number 13. So that right there, guys, is the equation that represents the information that I've been given in part D. Alrighty, so let's move on to the next type of question. Okay, so this question says, solve the following equations. Now guys, obviously we haven't learned the proper techniques behind solving equations. So all we're going to do now, as this chapter suggests, we're going to solve the equation using a trial and error method. So we're basically just going to think of numbers that will satisfy these particular types of equations. So let's have a look at the very first one. It says x plus 7 equals 10. Now we know that x is an unknown variable. We know x plus 7 equals 10 is simply an equation. So x, being an unknown variable, basically just represents a number. All we have to do to solve this equation here is to think of the number that, when used, will give us the number 10 at the end. So x plus 7 equals 10. So let's think of numbers that when we add 7 to it will give us the answer 10. So 1 plus 7 will give us 8. So that doesn't work. 2 plus 7 gives us 9. Again, doesn't work. 3 plus 7 gives us 10, which does work. So we know that x is simply equal to the number 3, because 3 plus 7 will give us the 10. So again, we're just going through a trial and error method to find the answers for these unknown variables. So let's have a look at B. It says 10 minus m is equal to 4. So again, m is just an arbitrary number. So let's think of what number, when we take away from 10, will give us the number 4. The number could be 10 minus 4 will give us 6. So that obviously doesn't work. 10 minus 6 gives us 4, which does work. So we just basically just working our way through in a trial and error method, finding numbers that will satisfy this equation. So in this case, m has to be equal to the number 6. 7w equals 21 is part C. Now 7w, as we know, simply means 7 times w, because in algebra we don't use the multiplication sign. We simply write the number and the letter next to each other, just like we have in part C. Basically that just says 7 times w equals 21. So now we need to think of numbers when we multiply by 7 will give us the number 21. So I'm hoping that we are all aware of our 7's times table. So 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. So in this case, w just simply equals 3. Now the next question says p over 3 is equal to 6. Now as we know, in algebra, we don't use the division sign. We simply write expressions as fractions. So p equals 3 equals 6. Now, we need to think of numbers when we divide by 3 will give us the number 6. So let's go through the 3's times tables, and that'll tell us exactly what we need to get in order to get that answer of 6. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, times 4 is 12, times 5 is 15, and times 6 is 18. If you think about it, 18 divided by 3 will give us that number 6. So in this case, P simply equals 18. Next question says C minus 8 is equal to 3. So a number minus 8 will give me 3. So think about what numbers when minus 8 will give me 3. 8 minus 8 will give me 0. 10 minus 8 will give me 2. 11 minus 8 on the other hand will give me the number 3. And then finally, guys, we have 4 plus h equals 11. Now for this, I want you to pause the video as we did before and have a go at this question on your own and see what number we need to get for h in order to get the final answer of 11. Alrighty, so I hope you've had a chance to have a go at this question. Basically, we need to figure out 4 plus what will give us the 11. Pretty straightforward. 4 plus 5 is 9, doesn't work. 4 plus 7 is equal to 11. So h in this case is 7. So guys, this is just simply using getting our minds to work with equations and using the trial and error method to solve these equations. As we go forward, we're going to learn proper ways to solve equations so we don't have to guess around. Obviously, these particular equations were fairly straightforward, so we could actually guess the answer. However, we will come across fairly complicated equations that we need to go through a proper method in order to solve them. Okay, so let's move to the next question. Okay guys, so let's have a look at this question. It says, use guess, check, and improve to solve the following equations. 4x plus 3 equals 3x plus 6 being the first one. So what we do here, guys, is basically we set up a table that has 4 different columns in order to display the value of x. The value of the left-hand side and right-hand side of the equations after substitution, and then we basically just do a comment to show how those two values compare to each other. So let's set up that table first. So column number 1 is basically the guess that we're going to make, just like we did before, for the x. Then the second column is our first expression, which is 4x plus 3, column number 2. Column number 3 is 3x plus 6. And then finally, column number 4 is basically just a comment that we're going to put as we make our way through the guesses. So now, guys, all we are going to do is basically guess some values of x here and then see if the numbers that we get happen to be equal to each other, because that will help us solve the actual equation that we have. So let's start with a random guess, but let's start with an easy number. So let's say our guess for the first part is 1. Now, if our first guess is 1 for the value of x, then that means 4x is simply 4 times 1. So we have 4 times 1 plus 3, which gives us the number 7. So when x is equal to 1, 4x plus 3 gives us 7. Then, if x is equal to 1, we have 3 times 1 plus 6, which is 9. So when x is equal to 1, we get 3x plus 6 being 9. So as we can see, guys, our answers are actually really close to each other. So the comment could be they're really close. That just tells us that we're pretty close to the answer already, just from our first guess. So since we've tried 1, why don't we try 2 this time and see how we go? So 4 times 2 gives us 8, plus 3 gives us 11. And then similarly, 3 times 2 gives us 6, plus 6 gives us 12. So 11 and 12, again, even closer. So we're even closer, so that can be our comment there. We're even closer to the answer. So I think 3 might just do the trick this time. So if we do 3 now, we have 4 times 3, which is 12, plus 3, which is 15. Then we have 3 times 3, which is 9, plus 6, which gives us 15 as well. So guys, there you have it. That's it. That's the answer. So we can write that's it here, whatever you like. So let's just go through the process here. Number one thing we did is we guessed. So that's the first part of the question. Part two is we checked. So these two columns can be the check columns. So we simply used our very first guess of 1, 2, and 3, and then checked the values that each of these expressions returned to us. And the final step that we did was the comment section, which basically told us how we can improve our answer. So since 1 gave us a close answer, but not quite the right answer, we went a little bit higher and then higher again until we found that x equals 3 is the right answer for this particular equation. So let's do the second one now. I'm just going to get rid of the workings here so we have a little bit more space. Alrighty, so I've already constructed the table for this particular question just to save us a little bit of time. So again, we go through the same process. Number one step we do is we guess the answer for the value of x to see if expression on the left hand side equals the expression on the right hand side. So again, let's start with a very simple one. Let's start with 1 and see what that gives us. So when we have 1, we get 2 times 1 here, because 2x is obviously 2 times x, plus 7, which gives us 9. Then we have 3 times 1, which is 3, minus 10, gives us negative 7. So we know straight away that the answer 1, or the guess of x equals 1, is way off. So we know that the value for 3x minus 10 is way too small. Running out of space here, so I'll just point to it and I'll go, it's too small. So we need to find another guess for the value of x, which is a lot higher. So why don't we try something like a lot higher? So let's try something like 13. Let's try that. So we have 2 times 13 plus 7, which gives us 2 times 13 is 26 plus 7 is 33. Then we have 3 times 13, which is 39 minus 10 gives us 29. There you go. We're already close. So again, guys, we're simply using the guess, then we check, and then improve method to solve these particular equations. So guys, please don't underestimate this particular method. It is very vital before you start solving equations. It just gets your mind ticking over on how you actually solve equations. Alright, so 13 was quite close. So why don't we try something like 17? See if that works. So we have 2 times 17, which is 34, plus 7 gives us 41. Then we have 3 times 17, which is 51, minus 10 equals 41. There you go. That's it. We have our answer. So x in this case is simply 17. So guys, it might take you guys, I don't know, 7 or 8 guesses, but just use the answers that you get in columns 2 and 3 to gauge if you need to really increase the number, really decrease the number, and so forth. So guys, for part C, I want you to pause the video and have a go at this yourself, and we'll have a go at it in a couple of seconds. Alrighty guys, I'm hoping you've had the chance to have a go at this question yourself. So let's have a go at it. We have, again, let's have a go at 1 as the very first guess. So 1 here will give me 3 brackets 1 minus 2. 1 minus 2 is simply negative 1, and 3 times negative 1 is negative 3. So remember guys, when a bracket and a number written next to each other in algebra is simply multiplication. And then we have 2 times 1 plus 1, which gives me 3. So we can straight away say that value for 3x minus 2 is simply too small. So let's improve the answer. Let's make it 5 this time. This will give us the 5 take away 2 in the brackets, which is 3. 3 times 3 is 9. And then this is 2 times 5, which is 10, plus 1, which is 11. So we're now close. So let's try 7. 7 minus 2 in the brackets, 5 times 3 is 15. 2 times 7 is 14, plus 1 is 15. So we have our answer. So guys, this lecture is running really long now. So I'm going to make another lecture for using trial and error and go through another type of question that you will be coming across in this particular chapter. So see you in that one.